don't mind that. That's not sketchy at all.
Alright, welcome everybody to part 3 of the Electric Surfboard Build. So just to get started here, I have moved again, which means a new workshop. This is 3 new workshops now, or the 3rd workshop in the past year and a half. I feel like I'm backtracking a bit, going from a single stall garage to a basement and now a finished basement room, but we're going to make it work. So what we're going to cover later in this video is more on the electronics and 3D printed parts of the electric surfboard. I'm going to go through the motor, why I picked it, and some of the specifications. The electric speed controller, again, why I picked it, and some of the limitations and advantages, and just a few other of the 3D printed parts that are a little unique to this build. I do want to include a way of getting those 3D printed STL files. At the end of this video, I'll list my email. If you're interested in doing something like this or using the design, you can easily email me and I will send you that STL file. A few people have asked for it, and I don't really have a good way of sharing it through YouTube, so I'll just supply my email. You'll get that at the end. As with this new workshop, as you can see, I am indoor. So just looking at some of the future of this channel, I will be focusing on more, I guess you could say, smaller projects. I won't be doing a whole lot of welding. I'll be focusing more on electronics, using battery-powered machines and things that are just on the smaller scale, I guess. I do think that's a bit of a switch up from the earlier projects of gas-powered rideable vehicles, but I still like making things that you can ride. It just comes down now to what I can actually build in this, you could call it, indoor workshop. A last note before we get into the electronics and 3D printed parts of this surfboard build, I just want to say thank you. I'm almost at 1,000 subscribers. Really exciting. I started this channel just to have fun and to share my ideas, and I've really enjoyed it since. So hope you enjoy the rest of the video, and let's get at it. All right, let's get right into the electronics I'll be using and the 3D printed parts to get this electric surfboard on the water. So the first up is the motor. Now this is a 56 123 kV 230 SSS motor. Now this motor is supposedly waterproof, and by that I mean water can get into it and it won't affect how the motor runs. That being said, if dirt and grime get into these open areas, you're going to have a big problem. This motor itself is rated at 9,000 watts, so it can handle high amounts of voltage, high amounts of current, and shouldn't burn out. That being said, we'll be running about 24 to 48 volts through it, depending on what speed controller we're using, and I'm hoping that's going to be enough. The kV on this, like I said, is 230. Most motors that handle just a direct drive for this application are normally around 100 to 120 kV. I'm going to counteract that by using a smaller prop, so that's going to be the goal. But this is what we're going to be using. We'll see how it works, and we'll get an update on that later. Alright, next big item on the list is the electronic speed controller. Now this is a Flycolor 150 amp 2 to 6 cell speed controller, and the reason I chose this was because it was relatively inexpensive. Most of these speed controllers for this application are rated for something like 300 to 400 amps with high voltages in the 48 to 60 volt range. The reason I didn't go with those to begin with is because this is relatively inexpensive, where those are hundreds of dollars. Now, I imagine I'm going to be upgrading at some point soon, but that's what we're going to start with, and we'll see how it goes. All right. The controller. This is off of eBay. It's just a simple waterproof skateboard controller. It was a little more expensive than I think it needed to be. I think it was something like 50 bucks, but the idea was that it's waterproof. I hope it stands up to that. It doesn't seem waterproof, but we'll give it a go. I've tried it with this motor and speed controller. Works well. It's just simple throttle, a nice small receiver here. I'm hoping it's going to work out just fine with the application I have it for. If in the future this all goes really well, I'd like to upgrade at some point to something that has like an LED display for battery power and all that. But for now, this is going to do it. Now, I think something that a lot of people underlook is the batteries. So you might have seen in previous videos, those flat packs. This is a big upgrade from those. And the reason I chose these was for a few that I'll mention right now. Just for the basics, this is a Headway brand 38120 lithium iron phosphate battery pack, which have a 3.2 volt nominal voltage, and these are rated for 200 amps continuous output, which is a massive amount of discharge rate for a battery pack. With this application, I imagine some of my amperages are going to be in the 100 to 200 range, which would outdo that speed controller, as I mentioned, but it's a good, safe place to be. A lot of times your speed controller motor can handle a lot of amperage and volts, but your battery packs will burn up if they discharge that fast. So this Headway pack, or this Headway cell, like I said, is rated for 200. It should be plenty of power output for whatever we decide to do. As you can see, I have about 30 cells there. I'm going to be hooking up a 6-cell configuration because that's what that speed controller can handle. But in the future, I may actually up that to more of the 36 to 48 volt range and see what kind of life we can get out of these batteries. Like I said, they're lithium iron phosphate, which is great. They're a little bit more safe than the lithium polymer or the lithium ion. They have less tendency to overheat and basically blow up during charging or discharging. So that was a big reason why I chose these batteries. I got them from Battery Hookup if you're interested. So some of the 3D printed parts here I'll go over. This is essentially what the undercarriage of the surfboard is going to hold. This will house the motor, essentially the coupler, and then at the very end you'll see, of course, the propeller within this housing. Now, the reason I chose this setup was for a couple. One is, and I'll show you here once I take this off, the motor will fit snugly within that aluminum housing, and I will be using a basically they sell different types of, I don't know how to put it, heat sinking goo that you can put around that motor, and this will act basically as a heat sink. So that's why I chose the aluminum over a 3D printed item. And then the motor mount itself, you can see the hole there. It will take electronics up and into the board, and this will be a nice mounting surface for that undercarriage. So put all together, I think it's going to be a real nice setup for the bottom. I try to make it as low profile as I can, and of course, if anything needs to change, we can always change it. One of the last parts here is the propeller. Now this is just a simple prototype I put together in Fusion 360, but when it comes to a motor that has a kV of 230 versus a kV of, let's say, 100, which you normally see, I can't use as big of a prop. So when I looked at some of the hydrofoil props they have, they're probably another 30% to 50% larger in diameter than this prop. So if I'm going to spin it faster, I'm going to need a smaller propeller so that I don't burn out the motor. So this is just an idea. I think I'll be playing with a lot of different designs and ways to reinforce and make it stronger. I do think I'm going to end up putting a layer of epoxy over this because it's just PLA. It's pretty brittle and it's pretty flexible too. But we'll get to more about what kind of props work best as I prototype and try. The last part I want to cover here, this will be the latching system for the top of the surfboard, and I'll show you how this is going to fit in a second. But essentially, I looked at a lot of different latches for the opening to electronics, and this just seemed to make the most sense. Just a simple screw-on. This will hold the board in place for the lid of the surfboard, and let me show you that right now. Okay, so pretty simple setup, and honestly, I looked through a lot of different options for different latching systems, and they all seem overly complicated, so I kind of came down to a pretty simple approach. Maybe not quite as sleek, but I think it's going to work really well. So each of these columns will sit in a corner of this center space for the electronics box, and the idea is that I'll put a hole through this lid that will go through each of the corners, and then these will screw right into these columns that sit underneath, and you'll just finger tighten them down. And I think it's going to work pretty well. It's simple, it's cheap, and also these columns, because the board will be sitting against them flush, will act as a bit of an extra structural integrity. So that's just my simple latching setup for the electronics compartment. Now, the electronics box itself, this is off of Amazon. This was about, maybe like 50 bucks. And this will house all the electronics, the speed controller, water pump, the receiver, and the battery. So it'll keep everything nice and dry. And of course, if I need to, I can just take it out, use it to remove, work on, and then charge batteries and whatnot. So real simple setup, and I think it's gonna work out really well. All right, just a couple items on a counter that I didn't cover yet. One is this waterproof fuse. This is a 100 amp fuse. I think I'm gonna upgrade this to 150 to match the speed controller. But this is just to safeguard all electronics, so just something simple that I'll add in as a sort of a protection agent. I know a lot of people might ask what type of wiring you use. This is 10 gauge silicone covered copper wire. It allows the wire to get extremely hot. I think the covering is rated to 200 degrees Celsius, so it won't melt. I have had wire coatings melt before, and it just kind of screws up the whole project. Like I said, this is a starting point for everything, so we'll see if I have to upgrade later. One of the second from last here, water pump. This is just simply for RC boats. It's just a simple water pump. I'll hook it up to a different battery, and this will keep the electronic speed controller cool as it is water cooled. And the last of the electronics is just a simple 200 amp. It's just a simple gauge. It displays voltage, amps, and watts. I don't know if I'll actually use this once everything's put together, but maybe for testing, we'll see. So yeah, that really concludes all electronics. Now, for the most part, this stuff is kind of all at a starting point for this project. I may upgrade the speed controller, I may upgrade the remote. I don't think I'll need to upgrade the motor, but we'll see. It's a testing phase, so this isn't really meant to get this thing blasting through the water, but it is meant to give me a good idea of what type of movement I can get out of a 150 amp speed controller, what I can do with this motor, and so on. So yeah, it's not really an end-all, but it's a good starting point for the project. Relatively inexpensive to start with, and we can get this thing on the water and get test driving and improve where it needs to be improved. And also, it wasn't outrageously expensive. Some people spend thousands of dollars on electronics for these projects. I want to start kind of in the middle to lower end and see what I could do with those electronics just to make it a little bit more affordable. But yeah, I hope you enjoyed this video. That's it for this. In the next segment, you'll see all this stuff being basically put into the boat, and hopefully at some point we can get a test drive. It's early September right now, so we'll see if we can do it this season, or if it will have to wait till spring. I hope not, but at the very least we can at least see it all go together and do kind of a dry test drive on it. Before I go, I do want to mention some other, or at least one other project idea I'm working on. It's basically electronic booster for a paddleboard. Something that is low power, will sit in the back of the board, and will basically just give a bit of a oomph. So that's sort of what's next on the plate. But for now, I do need to keep this project rolling. I tend to start a new project before I finish one, which basically delays everything. So more to come. If you have questions about this, please feel free to put them in the comments. And also, I will be linking my email shortly here. So if you're looking for any of the STL files on this stuff, you can get them. So feel free to reach out, and also reach out with any questions you might have if you're doing something similar in your own shop. But again, have a good day, and thanks for watching.